I
Twice.
checked your program. Some parts of your program are not correct. So, in fact, perhaps we should correct those things as well. But apart from that, you are, of course, most probably added this part as well there. So, what we should do, you should try to, I mean, I don't know at which level you are now. You will explain me in 20 minutes time or 10 minutes time. But first of all, let me talk with the other group, and then we will talk with you. All right?
Okay, doctor.
So I'm just asking to you, did you finalize up to the point I just mentioned to you, or you couldn't?
I
Because you
did,
are
doctor.
alone. You are alone. You should do all those things. Of course, you have some mistakes in the program that you have written up to this point, because last week I checked your program. There are some mistakes to be corrected, by the way. Yes, Okanda?
All right, doctor.
Now, what was the last thing that I just requested from you to do? Can you tell me?
Okay, you told me to take uh, five random values between minus
Yes.
1 and 1,
Yes.
and then you told me to edit uh,
You are
to the
obtaining five new vectors from the
exactly,
best vector, and then from these five vectors, you find the one which has the minimum function value,
exactly, yes,
and then compare it with the original solution.
yeah,
If the function value is better, you should replace it.
yeah,
Is this correct?
yes. I found the best solution, but I didn't do the replacing part, doctor. Like I just
I think
typed it
after
out. This is
finding
the
the
best
best
option.
one, the function value should be compared with the original one, and
Yeah.
then if it's better than that one, it should be replaced. Now, what I want to do, Okanda, because we have, in fact, what I should say, to be honest, this, I mean, the topics that you have selected, we started after the midterms. So we have only 4 or 5 weeks to finalize everything. That's a challenging thing, because if we started at the beginning of this semester, we will have more time. But since we have only 4 or 5 weeks, we have to do these things very quickly, and that's why we have a problem. That's why I'm saying we have to do it very quickly. So for your program, for your algorithm, Okanda, what you have done, I am repeating, we initially randomly selected the population. I mean, we just created, and then we calculate the function values. This is what we have done together.
Yes, doctor.
And after that, what we have done, we have
Recording in progress.
yes, what we have done, we have just, for your case, I'm saying, you just sort them and find the one which has the minimum function value. Is this correct?
Yes. Sort it out
And
in
then,
ascending order. Yeah.
yes, and then the one which has the minimum function value, you created five new solutions for that uh, solution,
Yes.
and find the one among these five, the one which has the minimum function value,
Yes.
and compare it with the original. This is what you have done. All right.
Yes, doctor.
Now, what I want you to do, let's say that we have initially 50 solutions, and let's say that you arrange them according to their fitness values. All right. So this is the function value or fitness value. Here we are using function value. And let's say that the minimum value is 0. I don't know, 5, then 0.75. So 0.98, 1.25. It goes like that. And I don't know, the biggest value here is 98.7. Most probably, you either changed the positions of these, and you said you did such a thing, if I am not wrong. Is this correct?
Yes,
You
doctor.
arranged them according to their function values.
Value, yes.
Yes. Now, what you should do, this one, whatever we have here, this solution is the best solution. I mean, I can just put 0.5 minus 0.50, and this is the function value. And to this solution, you created 5 new solutions. Is this correct?
Correct,
And
yes.
find the one which has the minimum function value. And the part that you didn't do, you should compare it with this function value. If that function value is less than this value, the new solution should replace this old one.
Yeah,
But
okay.
what this algorithm says, we have here, this is 0, 1, 2, it goes like that up to 49. Let's say we have here 50 different solutions. So the population size is 50 here.
Yeah.
So what you are going to do, let's say for the first 10 of them, 0 up to 9, for the first 10 of them, you will apply the same rule. That is to say, for the second one as well, if the second one, as an example, minus 0.5, 0.5, 0.5, for the second one as well, you are going to create 5 new solutions using this initial solution. From the 5 solutions, you will find the best one, and then the best one will be compared with this function value. If it's better, it will replace. Otherwise, it will not replace. So this should be done for the best 10 solutions. Is this
Okay.
clear?
Yeah,
Now,
clear, doctor. But can I ask you a question, please?
yes, yes.
Doctor, we selected initial 0.5 because at that moment, that's the best solution for us, right?
Yes.
But
Among all the solutions, 0.5 is the minimum function value.
yeah, exactly. What's the point of taking the next highest number? Is it gonna give a better number than the
Now,
one we
what
have
you are
before?
doing, you are perturbing these values. Is this correct?
Yeah,
When you are changing these values, it may be the case this 0.75 will decrease to 0.6, but this will not change. And this value may change to 0.75. So every step, the values for each solution, we are trying to get a better solution.
yeah, okay.
And it may be the case, I mean, in 2 or 3 iterations later, this 0.6 will be even less than this 0.5. That will be the better solution after these little perturbations,
Yeah,
after
okay,
these
sir.
little changes. So the idea for the first 10, we are going to obtain 5 new for each 5 new. That is to say, for each 5 different new, because they are going to be randomly added to this original solution. We discussed this. Now, what you should do, from 10 to 19, the second 10 solutions, all right? What you should do again, you should do the same thing, but this time, instead of obtaining 5 new solutions, you are going to obtain, let's say, 3 new solutions for each. So instead of 5, you will obtain 3 new solutions. And from these 3 new solutions, you select the best one and compare it with the original solution. Is this part clear?
Yes, doctor. But do I have to create random values between -1 to 1 in every step?
Initially,
Or
yes. As you have done in the first one,
yeah.
you should do the same thing for this one. All right.
Okay.
You will create random numbers and then sum them up, obtain another value, etc. All
Yeah,
right.
okay.
And interestingly, for the other, how many we have? We use 10 here. We use another 10 here. As a total, we have 50. So for this 30 solutions, These are the last 30 solutions.
Yeah.
What you are going to do according to this algorithm, just generate these 30 solutions again randomly in the interval maximum and minimum. That is to say, for the example that we are using, the maximum is 10 and the minimum is minus 10. So randomly generate these 30 solutions again. By the way, this doesn't say the first 10 and second 10 and the 30. I mean, you can change this. You may say the first 10 is 5 new, but instead of the second 10, you can say 15 of them here. We will create 3 new solutions and we will have 25 left here. 25 will be randomly what? Generated again. All right.
Yeah.
So this is the idea of the algorithm. When you write this part, it's the end of the algorithm, because after this we will have a for loop that will iterate these steps again and again. Let's say, I don't know, 5,000 times, something like that.
Okay.
All right. So this is your algorithm. The B algorithm is like just like this. And I hope before Friday, you can try to finalize it and mail it to me. And accordingly, even before Friday, we can come together. All right?